So chapter 8, section 2 is using properties of parallelograms. So everything we're going to talk about today, I'm not even on the screen, hang on. Okay, so chapter 8, section 2 is properties of parallelograms. We're going to talk about what they are and what is always the case with parallelograms. Now what's going to happen is we're going to talk about little pieces of things, and then this is all going to come together. By the end of this chapter, there's going to be so many things that you know, and you're like, wait, what were the rules for this, and what was the rule for that? And we're going to kind of Venn diagram it all at the end. So you're going to want to make sure that you stay up on this for those of you who are in other apps right now. All right, so a parallelogram, it's just a quadrilateral. It's a four-sided figure that has two pairs of parallel sides. So as soon as I say parallelogram, if I say this is a parallelogram, the things you know is it has two pairs of parallel sides. Notice that the top is parallel to the bottom and the left is parallel to the right, two sets of parallel sides. We call that a parallelogram. So when we write this symbol, we use this little box here. It almost kind of looks like a rectangle but tilted slightly. So right here is, when you see that, we would read this as parallelogram A, B, C, D. So you can use it in words. You can use it with a symbol. Either way, we know those things. Yes, ma'am?
Will there be a time that it's not quadrilateral?
No, a parallelogram will always be a quadrilateral. So the things that we know, so as soon as I say, hey, this is a parallelogram, even if it's not shown, these are the things you know. That the two opposite sides, like top and bottom, left and right, the ones that are on opposite sides, will be parallel to each other. So we could make the statement that AB is parallel to CD because that's the definition of a parallelogram. It's got, like, again, when we get to these things, the definition of a parallelogram says it is a quadrilateral with two pairs of parallel sides. So if I say this is a parallelogram, then by the definition, you know that it's got two pairs of parallel sides. Top is parallel to bottom, left is parallel to right. Yes, ma'am? It does not make them congruent. I'm so glad that you said that. Parallel and congruent don't mean the same thing, but you're going to question why I said that in just a minute. It doesn't, just because they're parallel doesn't mean they're congruent, but we're going to talk more about parallelograms and congruency in just a second. So understand, I'm going to kind of go back on that in just a second, but the parallel part, two lines can be parallel doesn't mean they're congruent. For example, like this, you don't need this for your notes, but just to show you an example, like a trapezoid. We know a trapezoid looks like this. And clearly the top side there is much shorter than the bottom side, but they could still be parallel. So parallel does not mean congruent. It doesn't mean that at all. They could be parallel and congruent, but it doesn't mean congruent, and that's what we need to watch out for. Okay, so here's what we know, and this is exactly what Colette just asked. And it says, if a quadrilateral is a parallelogram. So I say, hey guys, this is a parallelogram, then its opposite sides are congruent. This is not showing, those arrows there are not showing that it's congruent, they're showing that it's parallel. But they just told us that if it's a parallelogram, then additionally we know that the opposite sides are also congruent. So we're adding that in there. Now those are separate of each other. One thing says they are parallel, the other thing says they are congruent. So I just don't want us to get in the habit of when we see parallel that we think that means congruent too. It just so happens that in a parallelogram, it is always true that opposite sides are parallel, both sets of opposite sides, and both opposite sides are congruent. And I make that distinction because that's not always going to be the case. Sometimes things can be parallel and not congruent. So as you see in the diagram here, that AB, the left side, and CD are congruent. The top, BC, and the bottom, DA, are also congruent. So again, everything you're going to hear me say parallelogram, parallelogram, parallelogram over and over and over again today. Okay, here's more things that we know about a parallelogram. If a quadrilateral is a parallelogram, so if I say this is a parallelogram, then you know the opposite angles are congruent. So when we say opposite angles, we mean the ones that are in opposite corners here. Those will always be congruent. And these will always be congruent. That will always be true in every single parallelogram. It doesn't mean it applies to anything else other than parallelograms. So we know that angle A will be congruent to angle C, and angle B will be congruent to angle D. Yes,
How
ma'am?
do you know when they're not congruent? Are there
Well, if I say it's a parallelogram, that will always be true. Like, it's like if I say something's a square, you know, like it would be like saying, how do I know if it's a square that all the sides are equal? You'd be like, that's always the case. In every square, all the sides are equal. In every parallelogram, both of the opposite angles will always be congruent. So it doesn't mean that all four are congruent to each other. A is congruent to C and B is congruent to D. If you notice in that top picture there, A and C look like acute angles and B and D look like obtuse angles. So it looks like A and C are the congruent ones, B and D. It doesn't mean that all four are the same. Secondly, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary, meaning the ones right next to each other. Now, you already know this. I'm going to show you why you already know this, because a while back, so they're saying that the angles that are like next door neighbors, the consecutive ones, are already going to be complementary. And let me show you why we know this. Here is a parallel line. Here is a parallel line. Here is a transversal. So we know that these are same side interior angles, which must mean that they are complementary. Same thing on the bottom. Here is, we've got the left and right that are parallel. Here's another transversal down here. It must mean that these are complementary as well. They add up to 180 degrees. But not just those. If you look at the green lines are parallel, and so that would make this additionally a transversal. So we would get C and D will be complementary, and B and A will be complementary. Every angle will be complementary with the one that's like its next door neighbor, the one on each side of it. So take those, add them together, they will always equal 180 degrees. Colette, do you have a question? No?
I'm confused.
Okay.
Can you explain this?
Okay, so we know, let's talk about parallel lines for just a minute. Let's say these two lines are parallel, right? And I run a transversal across them. Would you agree with me that this angle and that angle right there are complementary, that they add up to 180 degrees? That's same side interior angles. We know that about them. And the same thing would be true about these two right there. Are you okay with that? Okay, now I'm going to draw the same picture, but just so it doesn't get too confusing with the pictures, I'm going to draw the same thing. Here's these. I forgot to mark these as parallel, parallel. So I'm not trying to draw something different. I just don't want to get too confused with all of it piled together. So let's say I have the exact same parallelogram, and now I'm looking at the left and the right. So if the left and the right are parallel, then this, oh, I did that as the left and the right are parallel. If I do the top and bottom as parallel, then this would be a transversal. If this is a transversal, it must mean that this angle and this angle are complementary. Excuse me, supplementary. Did I say complementary? I meant supplementary. If I said complementary, I think I said complementary. I meant supplementary. These two are supplementary. They add up to 180. I'm sorry. I think I did say complementary. I meant supplementary. So, here's the things that we know so far. I'm just going to summarize because, as you can see, it gets to be a lot. So we're not even done yet. We're halfway through. So let's say that I've got a parallelogram. I tell you something is a parallelogram. Here are the things that I know. If I say like A, B, C, and D is a parallelogram, well then I know that it has two sets of parallel sides. Each side is congruent with the side opposite of it. The opposite angles are congruent. And the consecutive angles, which we just saw there on the left, are supplementary. So there's a lot of things that are going on. We're only halfway through this slide. So there's a lot of things there. So you're going to want to keep your notes going at this point, and this is like a great way to start off your note cards. What are true about parallelograms? What are all the things I know about parallelograms? Because that's not all we're going to talk about. We're going to add on more things that are like more specific than parallelograms, things that don't fall into parallelograms. All right, adding on to that, if a quadrilateral is a parallelogram, then its diagonals bisect each other. The diagonals, nothing else, the diagonals bisect each other, meaning that this red line comes swiping through and it cuts the blue line and bisects it. And bisects it means what? Cuts it perfectly in half. So notice here and there. And then the blue line comes through and it bisects the red line. Each of them bisect each other. Now, here is the biggest mistake. I'm going to do this very slowly because the first thing I'm going to do is not true. Somebody does this. This is always what I see. This is the biggest thing I see that is a mistake. They leave the answer like this. It did not say that all four parts were congruent. It just said that they bisect each other. It may be possible that they're all congruent, but it really should look like that because they can be different lengths. The blue line does not have to be the same length as the red line, just that they bisect each other. So each one is cutting the other one in half. So in that case, we know that AZ is congruent to CZ, and we know that BZ is congruent to DZ. Okay, so let's go through the things that we know. Let's name all the pairs of parallel lines. So let's name them. Colette. Line segment AB. DC. That's. Notice the way that I wrote that. I made sure to list that they were line segments, and I listed that they were parallel. It would be a very bad thing, like it says name all pairs of parallel lines there. I'll tell you what somebody who's not going to get credit is going to do is they're going to write something like this. A, B, D, D, C, B, C, A, D. They're going to write some answer like that and expect me to sort out what's going on. That is not acceptable. That's not an acceptable answer. Make sure that you write it properly. It indicates that even if somebody had no idea what the question was, it's very clear what you are stating is that AB is parallel to DC and BC is parallel to AD. So let's name all of the congruent angles now. Yes, ma'am?
Angle B is congruent to D.
Angle B is congruent to angle D. That's, let me just mark those just so we can see it. I'm going to mark everything that we just did here. 1 second. Okay.
And then angle A is congruent to
Good. So this one is congruent to that one. Notice that the ones across from each other are congruent. I didn't mark them all as the exact same angle. That would not be true that they are all congruent to each other, just the ones that are opposite from each other. That's what I know to be true if you tell me it's a parallelogram. I can count on these things. All right. Name all the pairs of congruent segments. BE is congruent to which one? Sorry? DE. Okay. Are we okay with that answer? I'm not. He's not wrong. He's not wrong at all. He's just not done. It's like the second or third slide back. Go back to like the second or the third slide.
line segment AB is congruent to line segment DC.
Yep, so AB, this one over here. Let me mark the ones we've done. We've done this is congruent to that. This is congruent to that. Now we've got 3 lines I've got to do are congruent to that. So that's AB is congruent to DC. And what's the last one?
Line segment DC is congruent to line segment AB.
Yes, ma'am. Are they angle bisectors? No, not necessarily. They can be, but that is not something we know to be true. It's a good question. She's saying, is it true, like let's say that I know that this is 70 degrees. Like let's say I know the whole thing is 70 degrees. Is it true that that's 35 and 35? Not necessarily. It could be, but that is not a rule that we've got. So sometimes it could be, sometimes it will not be. That's not something that is always true. So we've discussed the things that are always true for these parallelograms. Anything else could possibly be true, but it doesn't mean that it's every single time. These things will be every single time. Alrighty. It says RSTU, so each one is RSTU. Let me just label this as, this one was not labeled RSTU. And I'm going to, in the case of the diagonals, I'm going to add a letter for the middle just because sometimes we might need that. So just to name things. So like we could say, oh yeah, this is this because of whatever reason. So let's start here. And we're trying to find X, Y, A, and B. In this case, there is no A. It's just X, Y, and B. Colette. Okay, we know the opposite angles are congruent. That must be true. Good. We know that these are supplementary. They have to add up to 180 degrees, which makes y 100 degrees.
Do we have any quizzes or tests this week?
No. Well, no. Yes and no. So here's, you don't have anything that's scored. That's a great question. So do we have any quizzes or tests this week? So you are going to, let me just hear this all out because it's going to sound too good to be true for a minute, and it is too good to be true. You have a take-home kind of quiz on Wednesday, but it's not scored as a quiz. Because our next thing that we're going to take is another test, I wanted to make sure that you saw the material for the quiz on like Wednesday. So on Wednesday, you'll kind of have like a partial quiz, 8-1 to 8-3. You'll take it home and work on it. It will be scored for accuracy, but it'll be scored as a homework grade, not as so I mean, I'm not going to give you a quiz to take home. I think I know what happens with those. Like everyone would just be like, what'd you get for this one? The more important thing is that you do it, you know how to. So I am going to score it for accuracy. However, I will, it will not count as a quiz grade. It's going to count as a classwork homework grade. So it's not as high pressure. What about, sorry?
We're not going to have another quiz grade
This week?
No, I'm saying before we take the next test, are we going to have a quiz grade?
No, not a quiz grade. No. You'll still have the same amount of quizzes and the same amount of tests, but it was important for me that you guys got to see kind of like, the whole point of a quiz really is like you kind of get a little idea of benchmarking how you're doing so far in the lesson. And so even though it just counts as a homework, it gives you an idea of what possible things might be on the test. Excuse me. How about B? Yes, ma'am.
Since the theorem on the RU is congruent to ST9, B is 9.
Perfect.
Do these theorems have names?
No, but we're going to be using them in the definition, and I'll show you how we're going to use them in a little bit. So the ones that don't have names, I'll show you how we're going to do them. Like, don't worry, we'll get to that part. Yes, ma'am.
We know that.
Oh, we're doing B?
I was going to Y.
We already did Y. We did X, Y, and B. If you want to take this one, you can.
Yeah, I thought we were on number.
Let's do letter B. Go ahead.
Did we know that B is 9 because, like, the second, it's not, RV, I guess.
Okay.
Is congruent to each
Why are those two segments congruent to each other?
because,
I don't need a name. Just what was it? What do we know about parallelograms?
they're like angle bisectors.
Not angle bisectors. No, that's what we said. We specifically said they were actually, we cannot count on angle bisectors. You're just using the wrong term. You mean something, but you're saying something else. What are those two things? What are those two lines going across the middle? Diagonals. So the diagonals bisect each other. That's how we know that in this case B is 9. What else? Yes, ma'am.
Y equals to, or Y equals, I think, 45 because opposite interior angles.
Ooh, I like that. Talk to me more about that because I was about to challenge you and then you came through clutch at the end. Talk to me about...
Okay, so first I was going to do 35 because I was like, maybe it's like consecutive. But then I realized...
So check it out. First she was thinking, oh, maybe that's 35, but then she backed out on that idea, and I'm glad she did because that would have been incorrect.
So then I realized that it's between two parallel lines.
Okay.
And I was looking over there, how is Y related to that? And I saw that the opposite side was 45, and I was like, oh, opposite.
Here's what she's seeing here, and it's exactly what you needed to see. Look at those two black lines. They are parallel. That red line is actually, I'm using the wrong lines here. Hang on a second. Here we go. Let's do this again. So we've got these two are parallel. For what she was asking for, I was using the wrong lines. So what we've got here is that if this one is 35, then these two would be alternate interior angles and it would make this one 35. Additionally, if she looked here and said this was parallel to this one, then we've got, using this as a transversal, we would have this one is alternate interior angles with that one. So notice that the alternate the alternate angles, the opposite angles are still congruent because 35 plus 45 is still equal to 35 plus 45. That's still 80 degrees in each corner there. Yes, sir?
That would be called alternate interior angles?
Because of this, she did this. This is alternate interior angles, what she did here, which is exactly what she needed to do. So if you're having a hard time seeing it, and then we've got this diagonal coming down. So what we've got there is, let's use the diagonal as a transversal here for a moment. Imagine here that the left and the right are parallel, which they are. Then it must be true that this angle right here and this angle right there are congruent to each other because of alternate interior angles. And the same goes for if the top is parallel to the bottom, and we have that same diagonal line, then this one would be congruent to this one, or 35 and 35. So that's why the two alternate interior angles are congruent. Okay? Here's where some actual work comes in. If you want to see the things that are probably more like your homework, here they come. What? Did we? I don't know. Did I leave something out? Oh, sorry. A and X. No, we did.
Isn't X the whole diagonal?
Yeah, I think X is the whole diagonal. Yes, I'm so sorry. There we go. What is A? 10. It's 12 because the opposite sides are congruent. And what is, X has degrees. Okay, so I think what they mean here is how many degrees, my brain's a little off there. X looks like it's this whole angle right there. If you were going to get that on a quiz or test, we would make that more specific there. That kind of looks like it's pointing at a line, and it didn't make sense that that was a line and they want it in degrees. If it's in degrees, then it's an angle. So clearly they want to say X degrees. How many degrees is that angle? So if I know that this right here, this one down here, is 45 plus 35, which is 80 degrees, and this one over here is 80 degrees, then how much is this one over here? Yes, sir? 100 degrees. Because the consecutive angles are supplementary. What would angle UTS be? UTS, which is here, UTS. What would that angle be? 100 degrees as well. Okay, let's do C. Talk to me about C. Yes, ma'am.
So we can do 4x equals 8.
Okay. So she knew that these two were congruent, so she set them equal to each other.
So, my 8 by 4, which is 2.
X is equal to 2. Okay. Yes, sir? Okay, keep going. All right, did we miss anything else there? It's just y and x in this case. All right. So we have to kind of play around with the things that we know. What do we know that's true about these things? And then I start working, well, what do I know? What can I figure out? Start with the things you know and keep working your way around. All right. Find the perimeter of parallelogram. Now that diagram right there states that this is a parallelogram. So what I'm about to draw is a parallelogram. And again, P-I-N-E. Go clockwise, go counterclockwise. Don't just put the letters anywhere you want. Either go clockwise or counterclockwise. And start wherever you want. It'll still work out. You just can't like cut across the middle. You can't go like P-N-I-E. So I'm just going to start labeling things. P-I is 12. I-N is 8. All right, see, once you have a diagram, this seems pretty simple as to what this is. So I need the perimeter. What am I going to do? Yes, sir.
Well, obviously you're going to figure out the correct sides. So
Okay.
you guys can do it to the end, and then I can do it to P, and then find the parameters, so you add all of them.
It didn't say inches or centimeters or miles. I didn't know what it was, so I just said 40 units. All right, that's it. You have plenty of time to get your homework done in class, so get that homework done first. Please don't make me come around and talk to you about what you're on your phone for or what apps you are using in there. Let's get this done first.